This is lesson 3, MBF3C version B, designing and constructing models. This unit tends to cause a little bit of grief to a lot of students when they first look at it. Certainly gives some concepts that are typically not really explored, especially in the high school math classes. You might need to draw a little bit more on some of the classes that you've done and experiences in your elementary classes. Designing and constructing models. So if we take a look through here, again, this is still building on the same idea and theme as geometry around us and why things are useful and why we should bother investing time in studying geometry. And you can see here the introduction is ultimately we're getting to building a DVD type of a stand at the end of this lesson, which is the final key question. Asking you to consider these different points within the lesson, explaining how object shapes and sizes affect their design, choices of materials, different volumes of containers versus their surface areas, dimensions that relate to maximizing volume and minimizing materials, which of course would reduce the cost of creating a container, and finally the plans that we talked about. Considering shape and size of the materials. Okay, so this is probably worth a bit of a read here. It's giving you some ideas about building or constructing typical things that we would use within our homes and why they would be built to particular sizes and shapes and the materials that are chosen to do them or to construct them. Okay, talks about a chair or sofa. Obviously it needs to be designed to be functional and comfortable, and would also need to be able to be moved in and out of a standard doorway, even beds as well, and some large furniture, a lot of large furniture that we have. It needs to be disassembled. It needs to be constructed in such a way that we can actually move these things in and out of the spaces that we live in. And sometimes there's no other way than to ship these large items in small pieces, and then they have to be assembled in the space that we're in. Again, just goes on here, gives more examples. Talks about the same type of thing. Materials. Depending on where these items are that we purchase need to be. If they're going to be materials that are just residing indoors, then we can assume that it's going to be a fairly stable, uniform environment, so we can use certain materials for doing that. Whereas if they're going to be items that will predominantly reside outside and exposed to the elements, then we need to take those materials into account as well. So the first support question here, it's asking us to consider this patio chair. Interesting that this lesson is giving us all the dimensions in imperial units. We can see it as 35 3/8 of an inch high, 29 3/4 of an inch wide, and 35 1/8 inch deep, and the weight is 36 pounds. Apparently this is made out of solid eucalyptus wood. I find that a little bit strange. And it's finished for outdoor use, and it's weather resistant anodized steel or brass hardware. I don't particularly see any hardware on there, but maybe there's some feet on the bottom, and maybe they're talking about I suspect they're talking about the fasteners, like the screws that are actually holding this thing together. So it asks you to describe the geometric shape shown in the chair. You can certainly look at the solutions at the back on page 141 or 149, I believe, for this lesson. But it's not that difficult to look at this and see that for the most part what we're dealing with here are rectangular prisms that are physically making up the chair itself. Now, they've been assembled in slightly different ways. We can see some triangular fan shapes on the back of the chair. We can see a bit of a triangular type of a design to the feet of the chair and the way they're laid out. But if we look at the actual materials that have been used to construct this chair, they're all made out of rectangular cubic type structures, rectangular prism type structures, because they're made out of pieces of wood, and that's the way wood is shipped to us and stocked and sold, and when they cut down trees, they cut them into these rectangular type of shapes. Has designer considered shape and size when he or she designed the chair? Part B. Well, I'm sure they did here. This chair is designed for a person to use it, probably an adult person. I've seen these types of chairs in smaller sizes for children, but just looking at the dimensions up top, probably made for a fairly average size adult to be able to utilize this chair and be comfortable. So that's certainly something that would need to be considered here. And again, since this is predominantly an outdoor type of a chair, it probably doesn't disassemble very easily, and it would be designed to move home to a residence and sit outside. Fact of the material choice being wood. Is there another material that this could be made out of? Well, you've probably seen these types of chairs formed out of plastic as well. There's things to consider there. Plastic tends to be more susceptible to degradation from the sun. It will wear down faster than wood will. Wood can be protected with different types of stains and paints. We've put a lot of time and energy into developing stains and paints and coatings for wood, since it's a material that has been used since recorded history for constructing different things that we use in our society. It can take a little bit more time to reflect on this and the answers at the back of the book. Minimizing the amount of material, obviously, as it says here, the more material you use when you build something, the more the object will likely cost to make. And because of that, most manufacturers usually try to minimize the amount of materials when they're making something. And they want to keep their costs down while still serving the design purpose of whatever it is that you purchased. The other thing that factors in there too is shipping weight. That's very realistic as well. Most things are shipped from all over the world, and the more something weighs and the larger the volume of space it occupies, the more it's going to cost to ship that to an end user as well. So that's not only is the cost of manufacturing, but there's also the cost of getting that to the intended customers. That's going to be increased as well. There's an investigation here about material in a can. We know the can is typically a cylinder type shape, and it talks about its volume in cubic centimeters. And we can look at this here. And it wants you to do an investigation based on the radius and the height. Now, we don't have access to this little model tool that it refers to here. That's no big deal. You could take some time and fill in the table knowing the H value and figure out the radius and surface area here of the can. Okay, and as it says there, keep changing the R value or adjusting the H value and see what the results are. And then it asks you here, what's the smallest possible surface area for a can that will hold a volume of 300 cubic centimeters? Well, that's just worth investigating yourself, or again, if you want to jump down to the solutions here for lesson 3, and you can see that the smallest surface area of the can is when the radius is 3.56 and then the height is 7.54. So moving along on this, still the same consideration. If you want to take some time to do those calculations, you can. I suspect you may have done something like that in grade 10, looking at optimizing surface areas and volumes and plotting those on different graphs. This next part dances around the idea of marketing, and they're calling it psychological, and then they're kind of one and the same, right? When a manufacturer creates a product that they want to sell, they need to take into account the marketing of that product in various ways. And one of the simplest and oldest sort of tricks in the book that is used is is illustrated here, in that cans that appear taller, given the same volume, give us the illusion that we're actually getting more than what we are than a shorter can. That same idea here comes into play often when you order a drink in a restaurant as well. You see somebody drinking a big tall glass. It has the illusion that you're getting more volume, so you'd be more inclined to order a large at a premium price, perhaps, versus a smaller container or a smaller glass that maybe in reality holds very little difference in the amount of volume. So what this is showing here again is the taller can and the smaller can side by each, but when you do the calculations, the volume is exactly the same, even though the taller can, if you were perhaps reaching for it on a store shelf, gives the illusion of having more product in it than the shorter one. Again, here's another exercise for a cereal box designed to hold a volume of 3,375 cubic centimeters of cereal. What dimensions for the box will minimize the cost of the box? And what dimensions would you recommend for the box, and explain your choice? Okay, so again, you need to draw on some, hopefully some experience that you recall back from grade 10 that you probably would have done to minimize costs of producing the box. And again, if you look at the back, to use that as guidance in the solutions here, on 149, I believe it is. Okay, the surface area right there. Okay, and looking at the solution here for the cereal box, we can see that the cost is going to be a minimum for the minimum surface area, which ends up being a cubic structure. And we take the cube root of 3375 and we find out that that's 15, so the length, the width, and the height should be 15 centimeters each. Okay. But I'm sure, as you would recall, there's probably not one cereal box out there that we see on a shelf that is actually a perfect cubic shape. There aren't many boxes that you do purchase products in that are perfect cube type shapes. They tend to be very tall, wide, rectangular shapes. Because again, now this comes down to sort of the psychology and the marketing of it, where the manufacturer displays a bunch of information to draw you in and to inform you about the product that you're purchasing, and so that's easier and more efficient to do if they can project a big, large surface area face of the box to you, the consumer. And so we don't see things that are necessarily most efficient in terms of their material usage for designing the box, but they're taking more into account the marketing approach and hoping to attract you by putting a big flashy pretty picture in front of you on a big surface area. Okay, so this is a bit of a subjective question here, or a solution. What do you recommend for the cereal box? Okay. So creating designs for useful things. Again, we've looked at a lot of these different parameters. The shape, the size, the type of the material, minimizing the amount of material, maximizing the volume, and now we're moving on to designing a real object. Okay. And again, it notifies you right here that it's understood that you don't have a lot of experience in this. Maybe if you've taken some manufacturing classes or some art classes or design classes, you might have a little bit more experience in designing things. But it's understood that you probably don't have a whole lot of experience here. So do your best and don't get too stressed out about this lesson. So the idea here is to go through designing a coffee table that includes a built-in magazine holder. Now this solution's worked through for you. You want an appropriate size for a coffee table, so it can't be too big. It needs to be something that would fit, typically in a living room type area in a normal residence. It needs to be a reasonable height. It's a coffee table, right? It's not going to be the same height as a kitchen table or a dining room table. or maybe even a desk table, or some type of a work table or a laundry table, things like that. This is a specific coffee table. So it talks here and explains some of these different things. It wants a magazine rack on it. Okay, something to hang magazines on. Now, the way the question is posed here and the way they're leading you through the design here is one option. It's certainly not the only option, but because it does need to hold magazines, now it needs to take those rack dimensions into account as well here. And you can see that the solution has opted for imperial measurements, which make perfect sense in terms of designing things based on the materials that we have to work with, and the purpose of the size of the magazine that needs to be held as well. If you measured magazines that you have, you'll probably find that they work out to be more standard imperial units than they would match up with standard metric units. So here's the sketch that it's proposing for this coffee table. Author suggests that it's an ugly design. Seems like a fairly practical design. They could have maybe put the rack underneath. I suppose being an ugly design is a matter of opinion. And so there's the drawing, and it wants you to create orthographic view of that coffee table. Okay, so creating the orthographic view, this is the next support question. Using a scale of 1 centimeter to 4 inches. Okay, so this is kind of interesting because the author here is suggesting mixing units, metric units and imperial units, which is fine. You can use any scale you want. You just need to define what that is on your drawing. And tells you how to go about this. And again, if you jump down to the solutions, oh, this is the orthographic. So that'll be the next part of the question. We'll go back to where we were for the scale drawing. Surprised it hasn't created a scale drawing. I would suggest that you could even use a standard piece of graph paper, a normal 1/4-inch graph grid paper. There's a link for some 1/4-inch grid paper on the resource page of the website, and there's one just on the MBF page as well. You don't have to use the 1 centimeter to 4 inch scale. Again, it's up to you, just as long as you indicate clearly on your drawing what your scale is. If you want to use a normal piece of graph paper, you could set that up so that every grid is 1 inch. You could set it up so every grid is 2 inches, whatever you want, as long as you specify in your scale what it is. Okay, so finally the crux of this lesson, the key question, is it wants you to design a stand to hold 50 DVDs. Now, I know a lot of you probably don't even have DVDs anymore because so much stuff is available online for streaming, or you can buy the movies and they exist in a cloud storage somewhere. But I'm sure you've probably got some experience with DVD cases, or even CD cases if you want, maybe a little bit older. For that matter, you could design this to hold any standard-sized group of objects. Maybe you've got a book collection and all the books are the same size. But if we stick with this here, this is pretty straightforward. If you want to deviate from the 50 DVDs, that's fine with me. Just indicate what it is you're designing your bookcase for, or your case for, your storage case for, and that will be fine on the lesson that you submit. If you have a DVD at home, probably a good idea, a DVD case, good idea to go measure that and get an idea of what the width and the height and the depth is of those different cases, or of one of those cases, a standard case. They're all pretty much a uniform case size. And then you're going to need to take that idea and use that to design your shelf or your case here, or your standalone type of a case. So this could be a shelf that hangs on a wall. This could be a standalone case that sits on the floor. There are a few parameters here that it wants you to include. It wants some type of a circular or curved shape in your design, and that doesn't mean the whole case needs to be circular or curved. It just wants some type of a circular or curved shape in the design. That might just be a curved, maybe a foot style of base. There might be a bit of a curve arch on that. There might be an arch design at the top. You might just have little arch type features on the bottoms of each shelf edge, something like that. So it doesn't indicate that you need to make the entire thing a curved or circular shape. So once you've sketched out a basic shape, it wants you to, or a basic design, sort of a three-dimensional sketch, then it wants you to create an orthographic design of your case. Okay, include dimensions on there, and in your solution, explain why you decided on the size and shape of your stand, including a rough sketch, like I said, and explain your choice of materials that you would use to build this. Okay, wood is usually pretty standard, but if you got some other ideas, that's fine. And again, the biggest chunk of marks here for consideration is coming up with a reasonable orthographic view of your case. So you want a front, you're going to want a side, and either a top, probably a top I would suggest, or maybe a bottom view, but certainly front and side, and then you decide what the third orthographic view is going to be that makes the most sense. Okay, good luck. Any questions? You can send me an email that you can connect through on the website.